Happy Friday, everyone. I'm so sorry that I can't be with you today, but here's what we need to get out. You need a notebook out, and you need your naming notes foldable. 2 things. And some sort of pencil. Okay? 2 things. Make sure you have those out. Once you have those out, we are today debriefing polyatomic ions, which you investigated yesterday through your POGL. Okay, so we're going to break down the difference between a monatomic ion and a polyatomic ion, and then we're going to add our polyatomic ion naming notes to our foldable. Okay, so in your notebook, we are taking notes today. They are pretty short, just on our difference between monatomic ions and polyatomic ions. So that is where we're going to start. These are all about monatomic ions versus polyatomic ions. Okay. Both of these words we can break down into their parts. Okay? Mon or mono means one, as opposed to poly, which means many. So we have one versus many. The atomic part of both of these just means atom. And as we learned last unit, ion just means that it has a charge. Okay, so our difference here is one atom with a charge versus many atoms with a charge. So we're going to break down what that means and go through our differences. To do that, we're going to look at an example of each. Okay, our example of a monatomic ion is going to be sulfur. Okay, now sulfur is the atom form. Use your periodic table to figure out what charge sulfur likes to form with a neighbor. Go. Hey, hopefully you were able to figure out that sulfur likes to form a -2 charge when it is an ion. In this case, we're talking about an anion, right? It's negative. We no longer call this sulfur, right? When it's an ion, it gets that IDE ending, so this is called sulfide. Okay? On the other hand, a polyatomic ion that you learned about yesterday and that you can find on the back of your periodic table, because that is where all of your polyatomic ion names exist, is sulfate. Okay, look on the back of your periodic table, see if you can find sulfate and write down the formula for that. Hopefully you were able to find it. It is SO4 with a -2 charge. That's sulfate. Okay, so we have SO4 with a -2 charge, and that is sulfate. Okay. Now, monatomic ions versus polyatomic ions. Where do we figure out their charges? How do we know their charges? All of these things. Let's start there. For any monatomic ion, it's either going to be, we figure out the charge from the periodic table, by looking at what main group we're in and figuring out how we satisfy the octet rule, or it might be on the back on our ions list if we're talking about a transition metal. Okay, all of our polyatomic ions. We find all of those names and charges on the back. All of this is on the ions list. Okay. Both of these can be cations or anions. Your cations are positive. Your anions are negative. That is true for both things. They can both be cations or anions. For the polyatomic ions, though, we are primarily anions. There's only one cation, and go ahead, look on your ions list, see if you can figure out what it is. Hopefully you found NH4 with a +1 charge. That is called ammonium. And that is our only cation polyatomic ion. Okay, let's break this down a little bit more. Sulfur. Holds the -2 charge. It is only one atom that's holding that charge. On the other hand, if we're talking about a polyatomic ion, you have in this case one sulfur attached to 4 oxygens. And all together, that group is holding your -2 charge. Now, the sulfurs and oxygens, those are held together by covalent bonds, which we're going to talk about next week. Okay? So, but it's important to know that these 5 nonmetals are covalently bonded. Okay. Now, both of these are ions, so they can both form ionic bonds. So let's look at an example of that. Let's look at what would happen in both cases if we bonded these with potassium. So we're going to do potassium and sulfur, and we're going to look at potassium and sulfate. Okay, potassium, find it on your periodic table. It's represented with a K. Remember, sulfur is represented with an S, so we're looking for K and SO4. Okay, go ahead, figure out your charge for potassium based on your periodic table. It is in main group 1, so it should have a +1 charge. This is your cation. Sulfur, we already discussed, should have a -2 charge. That's your anion. Potassium has your +1 as your cation. Sulfate has a -2 as your anion. Okay? In both of these cases, if we form an ionic bond, we can write a formula for each of these. So what I want you to do is try writing out each of your formulas. Okay? You can swap your charges for subscripts. Okay, hopefully you have done that. Actually try it on your own first. You should get K2S over here with your ionic bond. This is ionically bonded. Ionic bond. Let's name this. This would be potassium sulfide. It is an ionic compound. overall has a 0 charge. Okay. On the other side, let's look at this one. Okay, if we do the same thing over here, we swap our charges for subscripts, we form an ionic compound, we're going to get K2SO4. Now, the portion that is covalently bonded is the SO4, but this part is ionically bonded. Overall, we call this an ionic compound. Because your overall charge is 0. Okay. We're going to learn how to name this. Right now, though, I want you to brainstorm any questions we have about monatomic ions versus polyatomic ions with a neighbor. I will be back on Monday, and I would love to answer questions regarding those things. Okay, brainstorm any questions, write them down, be ready to ask them on Monday. Okay, in your naming foldable, we are doing our last section where we're specifically going to be talking about our exception of polyatomic ions. Okay, so this is your last section in here. It's at the bottom. And this is all about polyatomic ions. Okay. When we use polyatomic ions, generally they're anions, but regardless of what they are, the names do not change. Okay? To see those names, just look at your ions list on the back of your periodic table. To your ions list. Okay? The example we're going to do is we're going to look at magnesium and chlorate. So look on the back of your ions list and find chlorate. Okay. Chlorate is ClO3 with a -1 charge. Okay, figure out with your neighbor what the charge on magnesium is. Figure out your magnesium charge. Hopefully, we got a +2. Okay, we are gonna swap those charges for subscripts. Okay? When we do that, we get Mg1. We don't need to write the 1. And then we have ClO3, and we have 2 of those. Okay. Currently, it looks like I have 32 oxygens. That is not what I'm trying to say. I'm trying to say that I have 2 of my chlorates. Yesterday, you learned that you can put parentheses around those things if we have multiple of them. Okay, so we're going to use parentheses. Make a little note about that. Parentheses used when we have more than one polyatomic ion. Okay. Let's name this. Remember, cation first keeps its name. Magnesium. ClO3 is called chlorate. It also is going to keep its name because it's a polyatomic ion. So we now have magnesium chlorate. Okay, up front, you should find ionic compounds homework number 4. Okay, this is your last ionic compounds homework. It is not overly long. This is what you have the rest of class to work on. As we said, these are mostly anions. We do have one cation exception. That's what we're going to add to the front. We said that these are normally nonmetals and metals. Our exception here is NH4 with a +1 charge, right, which we call ammonium. Right? Fully made of nonmetals, but it is a cation. Okay? Please be nice to your sub. I will see you all on Monday. Have a lovely weekend, and you got this.